This is a narco-submarine used by the drug lords and is being pursued by an Overwatch aircraft. The aircraft uses cameras and sensors to track the submarine's movements, relaying the data back to the MQ-9 Reaper drones for real-time monitoring and coordination. But what is a narco-submarine? A narco-submarine, also called a drug semi-submersible, or low-profile vessel, is a covert craft built or adapted by drug traffickers to move large quantities of illegal drugs, usually cocaine, while avoiding detection by radar, aircraft, and coastal patrols. They range from crude, partially submerged boats to more sophisticated, fully submersible craft. Most smuggling vessels are semi-submersibles. They ride very low in the water so that only a small section of the hull or a narrow cockpit is visible. The hull sits just below or barely above the waterline, only a small conning area or snorkel protrudes. Visually, they're hard to spot and their radar signature is very small. From a naked eye at sea, these vessels are almost impossible to see. What's inside a narco-submarine? Step inside and you'll find cramped functional spaces designed to keep a small crew alive and the cargo hidden. At the front is a tiny cockpit where the pilot navigates. It's not comfortable, just enough room for steering instruments and someone to sit for long stretches. Nearby are backup generators used to restart the engine if it stalls. The internal layout is economical. Sleeping berths for a crew of 4 to 6, a small store of food meant to last a couple of weeks, a central fuel tank, and at the stern a heavy diesel engine that pushes the craft through the water. Often traffickers will pack the hold with several tons of drugs, dozens of bales stacked low in the hull. 12 tons of cocaine or other contraband is not unheard of on a single voyage. Smugglers are cunning about placement. Engines, fuel, food, and ballast are arranged so the vessel can ride extremely low or ride higher when necessary, making it harder to detect. In short, this placement helps it to become somewhat a submarine. Now the question remains, how did they bypass the US all these years? Well, to track these submarines, you almost require the full weight of the US military. To hunt these submarines, you need the Seahawks, the MQ-9 Reaper drones, and the US Navy, and lately the use of these AC-130 gunship. Let's take this scenario one of how they might use the aircraft. This is the AC-130. They usually serve as persistent, sensor-rich overwatch, watching, identifying enemy ground targets. From 10,000 feet up, the AC-130 watches everything. Heat signatures glowing against the cold water. The pilot circles patiently, tracking the target and aiming only to disable propulsion. The narco-sub surges forward, then, hearing the plane, tries to make a run. The gunner opens up with the 30mm Bushmaster gun but misses by inches. In one controlled burst, a 30mm precision round splashes into the water beside the sub, but the vessel begins evasive maneuvers and the shot does not hit its mark. Now the gunner can employ the 105mm howitzer. It has a much larger radius and coverage area. When ready, the crew fires. The first round impacts near the sub again. He can recalculate reloads, and his second round follows up to destroy the target completely. Just a reminder, these guns are made to destroy even a main battle tank. But before we move to scenario 2, let's take a look at how we fire these guns from inside this aircraft. Step 1. Verified rounds from the weapons system officer are loaded from this rack. Step 2. This controller on the left-hand side is used to adjust the position of the sensors or camera that is situated on the side of the WSO. While the controller on the right-hand side, however, is meant for firing the guns, which we will discuss later. Step 3. The pilot will leave a go-ahead with the consent switch in the cockpit and aligns the AC-130 gunship according to the target. Step 4. When the round is loaded and ready, he closes the breech just as shown in this animation. Step 5. The loader then hits F1 for confirmation, and then arm the 105mm howitzer. Step 6. Remember the trigger button. When all is set and done, he squeezes this button and booms open fire this 105mm howitzer. This bad boy can level down buildings and tanks from a range of 7 miles or more depending on the elevations. Step 7. The same goes for this 30mm Bushmaster. Combat System Officer and Weapons System Officer search for the target by using this left controller and fires the weapon using the right controller. When ready, he squeezes the trigger and booms open fires this cannon. It has an effective range of 5 miles or more depending on the elevation of the gun. obliterating any light armored vehicles or buildings. Let's simplify this process through this basic animations. This controller 1 on the left is used to adjust the position of the sensors or camera. On the right, there's a trigger for firing the guns. When it's time to fire the 105mm howitzer, the pilot initiates the process by aligning the gunship with the target using a consent switch. Once the round is loaded and ready, the loader closes the breech as demonstrated in the animation. Next, the loader hits F1 to confirm readiness and then activates the 105mm howitzer. With everything set, the WSO squeezes the trigger button and the 105mm howitzer roars to life, opening fire. Here they might be using the AC-130 gunship keeps watch from above, using advanced sensors to monitor the battlefield and spot targets. It sends real-time data to an MQ-9 Reaper drone, which confirms the target and fires a precision-guided Hellfire missile to eliminate it accurately. And finally, in Scenario 3, we have the Seahawk helicopter. But first, let's look how these naval vessels and aircraft work together to hunt down their targets. Amphibious warships, destroyers, and MQ-9 Reaper drones operate in a coordinated manner to strike narco-terrorist boats near Venezuela. The warships and destroyers act as command centers and launching platforms, deploying helicopters and surface-to-surface missiles for direct attacks. Meanwhile, MQ-9 Reaper drones provide continuous aerial surveillance and real-time intelligence, using advanced sensors to locate and track targets with great precision. These drones can also carry and launch precision-guided missiles to strike vessels. This integrated approach enables rapid detection, tracking, and multi-directional strikes, combining the firepower and mobility of ships and helicopters with the extended reach and endurance of drones. Together, they effectively intercept and eliminate narco-terrorist boats. Now let's take a closer look at the strategy and basic process of how MH-60 Seahawk helicopters are launched from amphibious warships. The operation begins in the Amphibious Ships Command Center, where intelligence about suspicious vessel activity is gathered and analyzed. Once a potential target is identified, preparations for launch begin. The MH-60 Seahawk takes off vertically or with a short rolling start from the ship's flight deck. Its folding rotor blades and compact design allow it to operate efficiently in the limited space available on the ship. As the helicopter quickly climbs to an operational altitude and moves toward the area of interest, it begins its hunt for targets. But how does it hunt its target search and acquisition? Using advanced onboard radar, electro-optical and infrared sensors, and communication links with the ship and other reconnaissance platforms, the Seahawk searches the waters for fast-moving vessels believed to be involved in narcotics trafficking. It integrates sensor data with real-time intelligence provided by drones or other assets to enhance target acquisition. After locating the narco-terrorist boat, the MH-60 Seahawk strikes with precision and coordination. It carries AGM-114 Hellfire missiles, which are advanced air-to-surface weapons designed to destroy or severely disable hostile vessels from a safe distance. Let's take a look at how these are used to hunt down fast attack boats. In addition to missiles, the Seahawk is armed with heavy machine guns, including the powerful .50 caliber Gauss-16 minigun mounted on either side of the cabin door. These guns provide sustained suppressive fire that is highly effective at disabling smaller boats, which might evade missile strikes or in situations where missile use is not feasible. The machine guns also deliver defensive fire to protect the helicopter, enabling continuous pressure on hostile vessels during interdiction operations. Together, these weapons allow the MH-60 Seahawk to carry out swift and accurate strikes on narco-terrorist boats. Whether engaging targets with Hellfire missiles from long range or using precision machine gun fire at closer quarters, the Seahawk demonstrates unmatched versatility and dominance over maritime threats and interdiction missions. But why use a Seahawk helicopter when you have a long-endurance drone? The MH-60 Seahawk helicopter holds a significant advantage in maritime interdiction missions due to its advanced anti-submarine warfare capabilities, which MQ-9 Reaper drones lack. Here is a detailed comparison highlighting these advantages. MH-60 Seahawk's advantage in anti-submarine warfare. The Seahawk is equipped with a dipping sonar system and can deploy sonar buoys to detect and track submarines underwater. Upon detection, the helicopter can launch a torpedo at the target. Once launched, the torpedo, equipped with its own sonar system, will actively track and pursue the submarine until it successfully neutralizes the threat. But how do these U.S. naval and aerial surveillance track the suspected drug boat for several weeks as part of an intensified anti-narcotics campaign in the southern Caribbean? This surveillance effort combined multi-source intelligence with persistent drone monitoring to identify maritime activities linked to narco-terrorists. The vessel under observation was a 4-engine speedboat, a type specially designed for high-velocity trafficking operations. Such boats typically travel at speeds ranging from 40 to 60 knots, which is approximately 46 to 69 miles per hour. This is around 74 to 111 kilometers per hour when traversing open water. Once the boat crossed from Venezuelan territorial waters into international waters, U.S. authorities positively identified it as part of a narco-traffickers operated smuggling mission, believed to be managed by the notorious Venezuelan criminal organization Tren de Aragua. Execution of the strike. Let us now examine how the strike was executed in detail. The MQ-9 Reaper drone responsible for the operation was most likely deployed from an amphibious naval task force operating in the southern Caribbean region. This task force included warships and Marines engaged in both exercises and active missions, from which MQ-9 drones routinely conduct surveillance and precision strike activities. These platforms provide the necessary launch and command capabilities for such unmanned aerial vehicles. The MQ-9 Reaper, an unmanned, remotely piloted aircraft, tracked the high-speed speedboat from above, continuously transmitting high-definition video and sensor data back to command centers and strike coordinators on the ground or aboard naval vessels. The MQ-9 has a maximum operational ceiling up to 50,000 feet and can loiter in the target area for up to 24 hours, affording it the endurance required to maintain precise real-time tracking of fast-moving maritime targets. After positive identification and receiving presidential authorization, the drone executed the strike by closing in on the boat. It launched a single AGM-114 Hellfire missile, a highly precise air-to-surface weapon capable of tracking and hitting fast and maneuvering targets with lethal accuracy. But how did this small missile could successfully track and hit the speedboat? Let's take a look at Hellfire missile tracking and guidance. The AGM-114 Hellfire missile is a precision weapon guided either by semi-active laser or millimeter wave radar. This means it can accurately lock onto and follow targets, even ones moving quickly on water, like a speedboat. The MQ-9 Reaper drone uses advanced onboard sensors and targeting pods to continuously track the boat, sending real-time information to the missile after it has been launched. The drone's sophisticated systems can calculate the boat's speed, direction, and maneuvers, allowing the missile's guidance to predict where the boat will be and adjust its flight path to hit the target. Speed and maneuverability matching. Hellfire missiles travel at speeds greater than Mach 1, over 760 miles per hour, 1,225 kilometers per hour, which far outpaces the speed of the boat. This allows the missile to quickly close the distance and make fine adjustments during its flight to strike a moving target. The missile's guidance system is designed to compensate for evasive maneuvers by tracking the reflected laser or radar signals bouncing off the boat. It continuously adjusts for changes in direction and speed as it hones in on the target. During the final moments, the missile locks onto the boat's heat or laser signature, greatly increasing the likelihood of a precise, successful hit even though the boat is moving fast across the water. Combined drone and missile capability. The MQ-9 Reaper's ability to maintain constant visual and sensor tracking of the boat provides the missile with necessary mid-course updates to ensure highly precise targeting. This powerful combination of persistent drone surveillance, the missile's incredible speed, and active guidance makes striking fast-moving maritime targets, like the Venezuelan speedboat traveling nearly 70 miles per hour, possible and highly effective. Paired with the MQ-9 Reaper drone's continuous real-time tracking, enable the missile to accurately follow, anticipate, and destroy a fast-moving boat traveling at speeds up to 69 miles per hour. We also make original engineering content, so please subscribe and hit the notification bell for more videos.